We're going to do some reviewing for lessons IN2 through IN4. The problems that we've got here are not in your book, so possibly you've gotten worksheets for these, but if not, you can kind of just watch what's going on and follow along. As always, if you go to the Savvas Realize website, is a good spot that you can go to get more practice besides what we're doing on the video here. So lesson IN2, if we look at this question number 3, there are two friends that are choosing a slice of pizza with one topping. Available toppings are tomatoes, jalapenos, onions, and eggplant. Use the multiplication counting principle to find the total number of possible total number of possible toppings combinations chosen between the two friends. Then write an organized list using the format friend1, friend2 to represent the sample space. Okay, so one thing we're doing is finding the total combinations. So if you think about this, we have the first friend, and we have the second friend. I like to draw blanks to be able to keep track of what's going on, and that helps me when I'm doing this multiplication counting principle. So for the first friend, we're just going to look at the different options they have. So their options are tomatoes, jalapenos, onions, and eggplant. So that is a total of 4 options. So I'm going to put a 4 on that blank. The second friend, they have the same options, so 4 options. Multiplication counting principle says if we multiply those, that's going to tell us how many different possibilities we have. So we have 16 different possibilities. The second thing they want me to do here is to make a list. And we're going to write these kind of like ordered pairs, like if we were graphing points on a coordinate plane. Friend1, friend2. They already did abbreviations up in the problem, so I'm just going to use those abbreviations. If they hadn't done that, it would be good that we would abbreviate, say let T represent tomatoes, let J represent jalapenos, etc. All of these start with different letters, so I mean it'd be fairly obvious what you mean, but always good to make sure you clarify what you're talking about. So if we list out our options, one way we could do this would be they both pick tomatoes. So that would be T, T. We could have tomatoes, jalapenos, tomatoes, onions, tomatoes, eggplant. There's different ways of doing this. I like to just do it this way, where I start the same way. Like in this case, the first friend picked tomatoes, and look at all those options. Okay. Now we could say, what if the first friend picked jalapenos? So we could have jalapenos, tomatoes, jalapenos, onions, jalapenos, eggplant. I've never heard of eggplant before on a pizza, but I've never had eggplant in general, I guess. So then we could have onions, tomatoes, onions, jalapenos, onions, eggplant. And then last, we could have eggplant, tomatoes, eggplant, jalapenos, eggplant, onions, eggplant. So there's a list, 16 different options. And that it's good because that confirms then, with what we did in the first part. We said there should be 16 options, and we've got 16 options. So we should be in good shape there. Number 5, we have a museum gift shop that sells hats with embroidered logos of the museum. So the hats are available in small, medium, and large sizes. and they're available in the colors red and green. So use the multiplication counting principle to determine the total number of possible hat variations sold at the museum, and then make a tree diagram. So once again, they're asking us to do two different things. Even if they don't ask you to use the multiplication counting principle, it's still not a bad idea to just do that. It doesn't take that long, and it helps confirm when you do the other part, when you work it out a different way, that you have all the options listed. So if you look at this, for doing the multiplication counting principle, I'm going to draw blanks for all the different options that I have. So one option that I have is the size. Another option I have is the color. So I need a blank for the size, I need a blank for the color. Okay, and then we're just going to look at how many options we have in each case here. So for the size, it could be small, medium, or large. So that's 3 options. For the color, it could be red or green. That's 2 options. And then, as the name suggests, multiplication counting principle, we're going to multiply those numbers together. So 3 times 2 is 6. So there should be 6 possible options here. The second part, they want us to do a tree diagram. For the tree diagram, you can start different ways. Since they mentioned the size first, I'm going to just work with the size. So I'm going to say small, and it could go to red, or it could go to green. Once again, you could choose to abbreviate, but if you abbreviate and just put like S for small, you need to make a note of that somewhere. We could also have medium, and that could go to either red or green. And we have large, that could either go to red or green. Okay, and then if you think about the different paths we have, here's 1 path, 2, 3, 4, 5, 6. That's 6 paths altogether, and we said we should have 6 different options, so that should be good. You could, besides doing it this way, you could start with the color and then go to the size. Okay, so I would need to clarify my abbreviations, but just to quickly mention, we could say red could go to small or medium or large. Green could go to small or medium or large. We'll look at some problems now in section 3. So number 3, we have a fair coin that's flipped. They say it's a fair coin, it's not like weighted, where it's going to land more on one side than the other. And we have a golf ball is randomly selected from a bucket that has 2 yellow golf balls labeled 1 and 2, and 5 white golf balls labeled 1 to 5. So list all the possible outcomes in the sample space. All right, for doing this, it's fairly common that you do H for heads and T for tails, so you know, it wouldn't hurt if I go ahead and clarify that, but and I'm going to work this down here because I don't think I'm going to have enough room maybe otherwise. If you want to, you could think of the multiplication counting principle before you work this out, just to make sure you get all the possibilities. We have a coin and we have a golf ball. So for the coin, possible outcomes would be heads or tails, so that's 2 options. The golf ball, we've got 2 yellow and 5 white. That's a total of 7. And so 2 times 7, we should have 14 different options here. Okay, so that's why I know that's going to be probably a little tight for me to write it all in that space there. Okay, so we could get heads, and we could get a yellow golf ball, and it says those are labeled 1 and 2, so let's say yellow 1. We could have heads and yellow 2. we could have heads and white 1, heads and white 2, heads and white 3, heads and white 4, heads and white 5. And then the tails are going to look the same. And if you notice what we did there, we've got 7 options. So 7 options for heads, we should have 7 options for tails, gives us 14 altogether. So tails in yellow 1, tails in yellow 2, tails in white 1, tails in white 2, tails in white 3, tails in white 4, tails in white 5. Okay, and there's our 14 options. I'm not done with the problem yet. There is a part B. What is the probability that either the coin will land on tails or a yellow golf ball will be selected? Okay, so what we're going to do is I'm going to look at the options here. I'm just going to circle what would work for either of these cases. So if the coin lands on tails, I'm not going to circle them individually, but any of those would work if it's tails. And then it says, or a yellow golf ball is selected. So here's 2 options where we have a yellow golf ball selected. Over here we also have options that yellow golf balls are selected, but those have already been picked. Okay, so we don't want to count them twice, in other words. So once we get to that point, if we count these off, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 options that worked out of our total of 14. So we've got a 9/14 chance. Probability is 9/14 that will either the coin will land on tails or we'll get a yellow golf ball, or maybe both. As long as at least one of those things happens, then we're in good shape. We could change that to a percent. We could divide 9 by 14 and then move your decimal 2 spots to the right would be your percent. Number 4, a tree diagram shows all the possible varieties of t-shirt available in the sizes small, medium, and large, and in the colors blue and yellow. What is the probability that a medium t-shirt or a large t-shirt is randomly selected? Okay, so what I'm going to do here, the tree diagram is fine, but for some people it might be easier for you to list these out as like ordered pairs. So we could have small blue, small yellow, medium blue, medium yellow, large blue, large yellow. Okay, to me it's just easier to look at them as separate things like this than looking at it on the tree diagram and trying to pick it out. So probability that a medium t-shirt or a large t-shirt is selected. So medium t-shirt, these would be options of a medium t-shirt. The large t-shirt would be these items here. So medium or large, we're okay with either one of those. That's a total of 1, 2, 3, 4. 4 out of 6, and you can reduce that to 2/3. So 2/3 chance makes sense because 2 out of the 3 sizes were either medium or large. A big thing when you do these problems, a lot of the problems are not necessarily that difficult, but we want to make sure that we take the time and carefully work the problem out before we just, try and fly through it and say, oh, this is easy and I'm just going to go to the next problem. Okay, take your time, make sure you got it right, work carefully, and then you can go on to the next problem. Number 7, a vowel will be randomly selected from the sample space A, E, I, O, U, and a number will be randomly selected from the sample space 1, 2. So they want us to draw a tree diagram to represent possible outcomes of randomly selecting a vowel and a number. And then we're going to find the probability of selecting an E or selecting a 2. Alright, so we're going to look at the tree diagram first. Before we do the tree diagram, if you want, we can do our fundamental counting principle or our multiplication counting principle. We're going to have a vowel and we're going to have a number. For the vowel, we've got 5 options. For the number, we've got 2 options. If we multiply, that's 10 options. So we should have 10 options altogether here. Okay, so we're going to do a tree diagram. So we could have A, and then we could get a 1 or a 2. E could go to 1 or 2. I, 1 or 2. O, 1 or 2. U, 1 or 2. Okay, so those are our options. If you look at the different paths that we've got there, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's good. So that's our tree diagram. And then for the probability of selecting an E or selecting a 2. Once again, I'm going to just write these out as ordered pairs. We could maybe look at the tree diagram and figure it out, but I would feel better if we list out the options. Okay, so selecting an E is one thing. So selecting an E, or selecting a 2. There's a 2. This one's got a 2, but it's already circled. I mean, you can circle it again if you want, I guess, but 2, 2, and 2. Okay, so that should be it. So if you count that up, 1, 2, 3, 4, 5, 6. That's 6 out of our 10 possible. Those are both even, so we could reduce that down. We'll always reduce our fractions if we can, so that would be a 3/5 chance. If you worked it out, it would be 60% chance as a percent. Section IN4, we'll look at some problems here, starting with number 1. So a teacher has 8 cards in a bag with different letters and numbers. She asked 2 students to pick a card out of the bag without replacing them. Okay, this is the dependent events we talked about. So what is the probability that both students pick a 1? Okay, so we want probability of a 1 and then a 1. So first student to pick a 1. If you look at the 1s, we've got 2 options that are 1s out of 8 total. Once one of them picks a 1, it's not put back in, so that would now give us, there would only be one other 1, and there would be a total of 7 options. So that's a 1/7 chance. Okay, I'm going to go ahead and erase this because I'm going to need these cards later. Okay, if you multiply straight across here, that's 2 out of 56. You could have reduced the 2/8 to 1/4 if you wanted. And then if you reduce those both by 2, that would be 1 out of 28. Part B, what is the probability that neither student picks a letter? Okay, so if they don't pick a letter, that means they're picking a number. So another way of putting it, they could have said, what's the probability that we get a number and another number? So if you look at the numbers, we got 1, 2, 3, 4, 5, 6. 6 numbers out of 8, or 6 things that are not letters, if you want to think of it that way. And then just imagine you pick one of these non-letters or numbers. So I'm just going to cross this 5 out. Doesn't matter which one, but just recognize that, we're imagining we picked one of the numbers. And then that would leave us with 5 out of 7 that are numbers. If you multiply that, would be 30 out of 56, which we can reduce to 15 out of 28. Okay, so a lot better chance of that happening than both students picking ones, we can see. And again, I'm just going to erase what we got up there so those are ready to go for the next problem. Part C, what is the probability that the first student picks a K and the second student picks an odd number? So K and then an odd number. So the K, there's only one K, so that's 1 out of 8. And then if they pick the K, chance of an odd number. So odd numbers, we've got a 5, a 1, a 7, a 1, and a 3. So that's 5 out of 7 that are left. 5 out of 7 that are odd numbers. And I'm just going to go ahead and erase here before I move this, otherwise it won't let me do it later as nicely. And if we multiply those together straight across, this would be 5 out of 56, and we can't reduce that. Part D, probability that the first student picks a letter and the second student picks a prime number. So for the letters, we've got 2 letter options out of 8. So probability of a letter would be 2 out of 8. And then we're going to imagine that we picked one of those letters. So just imagine we picked the A, let's say, and then a prime number. So prime number only has 2 factors, one in itself. So 5 would be a prime number. 1 is not a prime number. It's considered neither prime or composite. 7 is a prime number. 2 is a prime number. 3 is a prime number. So that's 4 out of 7 that are prime numbers. So 2/8 times 4/7. If you want to reduce ahead of time, you can. If not, you'll get 8 out of 56. And we could reduce those by 8. If you don't see it, just keep reducing by 2s until you get to this point. This would reduce all the way down to 1/7. Number 3, an 8th grade class must send 3 students to represent them at the science fair. Of the 12 students that meet the requirements, 7 are boys and 5 are girls. To determine who will go, the teacher picks the names of the students out of a bag without replacement. What is the probability the teacher picks 2 girls first and a boy last? Okay, so we're wanting the probability of a girl, and then a boy. So once again, if you want to just write out what's happening here, we've got 7 boys and 5 girls. Whoops. Okay, you can circle those or put them in boxes, whatever, but this might be a good way to help you visualize what's happening. So first, if we pick a girl, there's 5 girls out of 12 total. Okay, and then that person's not going to be chosen again, so we'll X them out. And now picking another girl, there would be 4 out of, there's 11 left now. And then we'll X them out. And now picking a boy, there are still 7 boys left out of 10 left. 7 out of 10. Okay. If you multiply, this would be 140 out of 1,320. And we can reduce that down to 7 over 66. Okay, and remember, there is a way, if you're allowed to use a calculator, there's a way of getting the reduced fraction on your calculator, but otherwise, if you just keep at it, keep trying to reduce it down, you'll get it to that point. Number 5, the Spend Less supermarket is handing out flyers to the first 30 customers who arrive at their grand opening. There are 18 flyers that contain extra coupon savings. What is the probability the first 4 customers receive flyers without extra coupon savings? Okay, so we could write all this out, but basically we're wanting 4 people to not get the extra coupon. Okay, I'm doing N for not. If you want to use a different letter, that's fine. Okay, so the first one, if there's 18 that have it, that means there's 12 that don't have it. So 12 out of 30 that don't have it. Okay. Once we've picked that, now there's only going to be 11 that don't have it, and there's 29 left. And if that happens, now there's only 10 that don't have it out of 28 left. And then finally, there would only be 9 that don't have it out of 27 left. Okay, we could definitely do some reducing on these. Even, for example, 9/27 you could reduce to 1/3. If you don't do any reducing, you'll get 11,880 out of 657,720. And that reduces actually down to 11 out of 609. Okay, so just to mention here, if you did do reducing ahead of time, like I said, the 9 and 27 you could reduce to 1/3. 10 and 28 you could reduce by 2. 12 and 30 you could reduce by 2. And then also you could reduce by 3. And then if you work that out, you would get that. Oh, sorry. We could now then reduce the 2 and the 14 as well. And we could reduce these 5s. Okay, then you would get 11 out of 609. Okay, mainly focus on the initial problem, okay? The reducing part, you know, that's part of the problem, but it's not as big of a part as getting the initial setup correct. Number 6, a bag contains 10 yellow, 10 red, and 10 orange wristbands. Explain the difference between the probability of picking 3 yellow wristbands with replacement and the probability of picking 3 yellow wristbands without replacement. Okay, so basically, without replacement, the probability is going to be lower of this happening, because if we don't put it back in, there's not going to be as many yellow wristbands on the second and third picks. Instead of every time there being 10 yellows, if we don't replace them, there'd be 9 yellows, and then there'd be 8 yellows. So this gives you a little bit of an idea of what we're doing in lessons IN2 to IN4. Once again, try to look at some problems, work through problems on the Savvis Realize website as well to get some more practice. look over assignments you've done, things like that. Make sure you ask questions. Have a good day.